In this video, we're talking a little bit about UV radiation and skin cancer. Remember, when we talk about UV radiation, we're talking about radiation that comes from the sun. There are other sources of UV radiation, like tanning booths, black lights, curing lamps, but the sun is really our main source of exposure. The main problem with UV radiation is that it damages our DNA, and it damages our DNA both indirectly and directly. Indirectly, UV can generate highly reactive molecules that disrupt both DNA and proteins in our cells. What you're seeing here is direct damage of DNA by UV radiation. When UV radiation comes in and hits a DNA molecule, it causes neighboring thymine nucleotides on the same DNA strand to link together, forming thymidine dimers. These dimers can't be read properly by DNA polymerase. So, when this DNA is replicated, the thymidine dimer causes a change in the DNA sequence. It causes a mutation. This is a problem because when your cells accumulate mutations, they're more likely to turn cancerous. There are 3 different types of skin cancer: basal cell carcinoma, squamous cell carcinoma, and the one that's most closely associated with UV exposure, melanoma. There's some evidence that UV exposure plays a role in both basal cell carcinoma and squamous cell carcinoma, but melanoma, UV exposure is really the main risk factor. Basal cell carcinoma is the most common cancer in the US. Thankfully, it's also the least dangerous. It's very slow growing, and it's the least likely to spread throughout the body. It's called basal cell carcinoma because it arises from the cells of the stratum basale, and it looks like these shiny dome-shaped bumps. Squamous cell carcinoma is the second most common type of skin cancer. This type of cancer grows more rapidly than basal cell carcinoma and is more likely to spread. If you haven't seen the term metastasize before, that's basically what it means, to spread throughout the body. If a cancer metastasizes, that's a very bad thing because now it's everywhere, and there's a chance that it might go to your bones and start eating away at your bones, or go to your brain and start disturbing your nervous system. Plus, no matter where it goes, if it is spread throughout the body, it means that you can't cut it out anymore. You can't remove it surgically. So squamous cell carcinoma, a little more dangerous because it's more likely to metastasize. This type of cancer comes from cells of your stratum spinosum and often presents as this kind of a scaly red patch like you're seeing here. Now, melanoma is more rare, but it is becoming more common in the US. And this is a very bad thing because melanoma is both highly metastatic, meaning it's very likely to spread throughout the body, and it's resistant to chemotherapy, meaning that it's harder to treat than the other types of skin cancer. Melanoma is a cancer of the melanocytes, the pigment-producing cells of the skin, and the number 1 risk factor for melanoma is exposure to UV radiation, to sunlight. The more UV radiation you're exposed to, the more likely you are to develop melanoma. Melanoma, like other cancers, is easier to treat and much more survivable if it's caught early. One problem with catching melanoma early is that it's easily mistaken for an ordinary, harmless, pigmented spot on the skin, like a freckle or a mole. So there are a set of guidelines, the ABCD or ABCDE rule, that help us distinguish between a harmless mole and melanoma. There are 4 guidelines in the ABCD rule. Sometimes a 5th gets included, making it the ABCDE rule. A stands for asymmetry. If 2 halves of a mole don't match, it might be cancerous. B stands for border. Melanoma often has an irregular, ragged border. C stands for color. Moles are usually a single color. Melanoma will have different shades. D stands for diameter. Non-cancerous moles usually are no larger than a pencil eraser. So if the mole is larger than a pencil eraser, it might be melanoma. E, the fifth factor that some people include, stands for elevation. Melanomas may be raised from the surface of the skin and have more of a rougher texture. There are also other signs that a pigmentation on the skin may be cancerous too. If it's bleeding, if it's tender, if it's itchy. The itchiness is often what gets people in to see the dermatologist. But really, if you have a mole that's showing any of these signs, you should get it checked out by a dermatologist, and you should get it checked out soon. Because like I said, it's easier to treat if you catch it early. Skin cancer isn't the only negative effect sunlight has on the skin. UV radiation also causes clumping of elastic fibers and breakdown of collagen fibers. And this image here is a striking illustration of what this does to your appearance. It's taken from the New England Journal of Medicine, and it's a photo of a 69-year-old man who drove a delivery truck for 28 years. So, for 8 hours a day, 40 hours a week, the left side of his face was continually exposed to sunlight. But the right side of his face was fairly protected, facing towards the interior of his truck. You see the difference? UV exposure leads to thickening of the epidermis, leads to wrinkling, a loss of elasticity, dark patches of melanin production. Sometimes you'll hear these referred to as age spots or liver spots. Think about this the next time you or someone you love wants to go tanning. A tan comes from increased production of melanin, that brown-red pigment that's your skin's natural protection against sun damage. So a suntan is really just your skin's desperate attempt to provide some protection against the damage that's being done to it. Now, all of this being said, I want to make the point that UV radiation is not all bad. It does serve a very important function. UV radiation stimulates the production of a precursor to vitamin D. That's over here, cholecalciferol. Cholecalciferol, also known as vitamin D3, is converted to the active vitamin D, calcitriol, in the liver and kidneys. It's actually a two-step process. One reaction occurs in the liver, and the second step occurs in the kidneys, making calcitriol. Production of cholecalciferol is an essential metabolic function of the skin. So your skin needs some UV exposure in order to make cholecalciferol, which can then be converted to calcitriol through the activities of the liver and the kidneys. Calcitriol, active vitamin D, is absolutely essential for bone health. It aids absorption of calcium from your diet. So if you are missing vitamin D, you will develop over time soft, poorly mineralized bones, which may deform from the weight put on them, like you're seeing here, in a disorder known as rickets. There's a lot of interest in vitamin D and all the things that it does for us. There's been some evidence that vitamin D may also help inhibit non-skin cancers, may help limit autoimmune diseases, may even help protect against heart disease. So while there's still a lot of research being done on vitamin D, I think it's becoming pretty clear that this is a very important molecule in our bodies. That's not to say that you have a license to spend as much time as possible out in the sun unprotected. If you are fair-skinned, you really only need a few minutes without sunscreen in the sun in order to generate enough vitamin D. If your skin is darker, you have more melanin in it, and you need a little bit longer time in the sun, but we're still talking 15 to 20 minutes. We're not talking sitting out on the beach all day long. The effectiveness of vitamin D production does vary depending on latitude. Here in the Northwest, vitamin D deficiency is actually thought to be pretty common since we get so little strong sunlight in the autumn and winter months. It's thought that we essentially don't get enough sun during the fall and winter in order to produce vitamin D. Thankfully, we can get it from dietary sources as well. These are the questions you should be able to answer after studying this video.